Have you ever pondered the possibility of life beyond Earth? Have you ever looked up at the night sky and wondered if we are truly alone in this vast universe? As we journey through the cosmos, we find ourselves drawn towards the icy moons orbiting our giant gaseous neighbors. One moon in particular has captured our attention and sparked our curiosity. Europa, one of the largest moons of Jupiter and the sixth closest to the planet, Europa has been a subject of fascination since it was first observed by Galileo Galilei in the early 17th century. This intriguing celestial body, primarily made of silicate rock and covered with a water ice crust, is believed to harbor a saltwater ocean beneath its icy surface, an ocean that could possibly contain the chemical elements necessary for life. Today we delve into the mysteries of Europa, a celestial body that may hold the answers to our questions. Europa, the sixth closest moon to Jupiter, is one of the over 90 moons orbiting the giant planet. This icy celestial body has a rich history that dates back to the dawn of modern astronomy. Its discovery, along with its three sister moons, Io, Ganymede and Callisto, marked the first time humans identified moons beyond our Earth. This quartet of moons, known as the Galilean moons, owes its name to the Italian astronomer Galileo Galilei. It was Galileo, with a homemade telescope in the dark winter of January 1610, who first spotted these distant points of light. Among Jupiter's moons, Europa holds a special place. It's the smallest of the Galilean moons, yet it ranks as the sixth largest moon in our solar system. The moon's position, nestled between Io and Ganymede, puts it in a celestial tug-of-war. This gravitational dance with its neighbors and Jupiter itself causes Europa to have an elliptical orbit, which in turn leads to tidal heating, a key factor that might make Europa a hospitable place for life. Europa is primarily made of silicate rock, with a crust of water ice that glimmers in the far-off sunlight, painting a picture of a cold, icy world. But don't let its frosty exterior fool you. This moon is anything but boring. Its surface, while icy, is a complex maze of cracks and streaks that tell a tale of geological activity. The relative lack of craters suggests a young, active surface, hinting at the dynamic processes happening beneath. Europa, despite its cold and distant nature, holds a unique fascination for scientists. Its icy exterior hides a secret world beneath, an ocean holding twice as much water as Earth's global ocean. Could this distant moon harbor life? This question drives our exploration, our curiosity, and our unending quest to understand our place in the universe. Europa is a world of contrasts, composed primarily of silicate rock with a water ice crust. This icy exterior, combined with Europa's distance from the sun, makes it one of the coldest places in our solar system. But don't let the chilly temperatures fool you. There's more to this moon than meets the eye. Beneath the frosty surface of Europa lies a composition much more dynamic and intriguing. A closer look reveals that beneath the icy crust, Europa is primarily made up of silicate rock. Silicate rock, common on Earth and other terrestrial planets, gives Europa a solid structure. But what's really fascinating about Europa is what's likely at its very core. Scientists suspect that the heart of this moon could be an iron-nickel core. This core, much like Earth's, could be generating a magnetic field, though much weaker than ours. Now, if you were to take a stroll on Europa's surface, you'd notice something interesting. Unlike our moon, which is heavily cratered, Europa's surface is relatively smooth. Craters are few and far between, suggesting a young and active surface. Instead, the landscape is dominated by a network of crisscrossing cracks and streaks, signs of geological activity. These cracks and streaks tell us that Europa isn't just a static, frozen world. They hint at a dynamic, possibly tectonic activity beneath the surface. This could mean that the icy shell on the surface is floating on a subsurface ocean. Speaking of oceans, beneath the ice, scientists believe lies a saltwater ocean. This ocean is thought to contain more than twice the amount of water as Earth's global ocean. This makes Europa one of the most promising locations in our solar system to find environments suitable for life as we know it. Now imagine this, a world of silicate rock, with an iron-nickel core, covered by a water ice crust, hiding a vast, salty ocean beneath. That's Europa for you, a moon of contrasts and mysteries. The icy surface of Europa hides a world that is much more complex than it appears at first glance. And as we continue our exploration, who knows what other secrets this icy moon will reveal. Europa's atmosphere, though thin, is composed primarily of oxygen. Now let's delve into the fascinating details of this celestial body's atmospheric conditions. Unlike our home planet, Europa's atmosphere is exceptionally thin, So thin in fact that it's more accurate to label it an exosphere, an outermost layer of an atmosphere that gradually fades into the vacuum of space. Despite its thinness, however, Europa's atmosphere plays a pivotal role in painting a picture of this moon's intriguing potential. The primary component of Europa's atmosphere is oxygen. Now don't jump to conclusions too swiftly. This isn't oxygen as we know it, the type we humans breathe in with every lungful of air. Instead, it's the result of a process called radiolysis. When Jupiter's intense radiation splits the icy surface of Europa, it leaves behind a byproduct of molecular oxygen. This oxygen doesn't build up to form a thick atmosphere, because it's constantly being siphoned off into space or locked away in the moon's icy crust. Yet, its mere presence is fascinating to scientists, hinting at the complex processes taking place on and beneath Europa's icy shell. What's more, this oxygen-rich atmosphere contributes to the likelihood of Europa's potential to harbor life. Although the oxygen generated through radiolysis isn't directly breathable, it's a key ingredient for life as we know it. It's thought that if life does exist in Europa's subsurface ocean, this oxygen could potentially diffuse through the ice and into the water below, providing a source of energy for any life forms that may reside there. Europa's thin yet intriguing atmosphere is a testament to the moon's dynamic nature. It's a beacon in our ongoing quest to understand the universe and the potential for life beyond our own planet. This thin layer of oxygen, though not breathable by human standards, may be a key factor in Europa's potential to harbor life. As we continue to explore and understand Europa's atmospheric conditions, we edge ever closer to answering one of humanity's most profound questions: are we alone in the universe? Beneath the icy shell of Europa, scientists believe, lies a saltwater ocean with twice as much water as Earth's global ocean. This revelation has catapulted Europa to the forefront of extraterrestrial life research. But what makes this moon of Jupiter so special? And why does it hold such potential for life? The answer lies in the very nature of life as we understand it. Life on Earth in all its varied forms thrives on water. From the smallest microorganism to the largest whale, water is the common thread that intertwines the story of life on our planet. And where there's water, there's a chance for life. Europa's vast ocean isn't just made of any water though, it's salt water, much like our own seas. This similarity is of great interest to scientists who theorize that the same chemical reactions that led to life on Earth could potentially occur in Europa's salty depths. But water alone isn't enough. Life also requires certain chemical elements like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These are the building blocks of life as we know it, the ingredients from which all living things are made. The possibility that these elements might exist on Europa is another reason why scientists are so excited about this icy moon. In order to explore these theories, NASA is launching the Europa Clipper mission in 2024. This spacecraft will journey to Europa, equipped with a suite of scientific instruments designed to investigate whether this distant moon has the capability to support life. It's scheduled to enter orbit and begin its search in 2030. The mission will analyze the composition of Europa's surface and subsurface, looking for signs of these essential elements. It will also probe the thickness of the moon's icy shell and the depth of its ocean, seeking to understand more about the potential habitats that might exist beneath the surface. Europa, the icy moon of Jupiter, may indeed hold the key to understanding the possibility of life beyond Earth. As we continue to explore our solar system, Europa stands as a beacon of hope, a testament to the potential for life in the seemingly inhospitable reaches of space. Europa, with its icy surface and hidden ocean, continues to captivate us. It's a world of tantalizing mysteries, a celestial body that teases us with the possibility of life beyond Earth. This moon of Jupiter, the sixth closest to the gas giant, is more than just a pretty celestial object. Beneath its surface, a saltwater ocean twice the size of Earth's global ocean beckons, possibly harboring the key ingredients for life. Europa, primarily composed of silicate rock with a water ice crust, is a study in contrasts. Its surface, crisscrossed with cracks and streaks and relatively few craters, hides an iron-nickel core. Its thin, oxygen-rich atmosphere adds to the enigma. And yet the biggest question remains unanswered: does life exist here? NASA's upcoming Europa Clipper mission, set to launch in 2024 and enter Europa's orbit by 2030, aims to investigate this tantalizing possibility. As we continue our exploration of the cosmos, who knows what secrets Europa may reveal about the possibility of life beyond Earth?